was the answer. Oh wait, yeah, it was x squared root of 5, yeah.
Okay, to finish this up, we're going to talk now about the quadratic formula and then a specific part of the quadratic formula, and then we'll end with an application problem. So yesterday we talked about factoring again, and really the only difference is that we just emphasized that you do need to set them equal to 0 so that you can actually get the solutions. Then we talked about the square root property, which we kind of just saw in our bell ringer when you're moving everything over to the other side and getting the x squared by itself. And then we ended yesterday with the completing the square method. So the quadratic formula is used when maybe you run into a situation where factoring doesn't work out very nicely. Completing the square maybe isn't the easiest or best route to go. Quadratic can be used on anything and everything when it comes to these types of equations. You don't need it to be in a specific form or have so many terms or anything like that. So a lot of times if I try to factor it first and if I can't think about it quickly or I can't really see where it's going to go, or if I try to use like the completing the square, but it doesn't look like it's going to work out. Like if the number in front of the x squared isn't a 1, I'm probably going to avoid completing the square if I can. And so sometimes I'll have to end up using the formula here. And we talked about yesterday how maybe when you guys were in a previous class, like in algebra or even last year in algebra 2, we did learn about this formula and there is a song that goes with it. Okay, but does anyone remember just what the quadratic formula says? Or any part of it at all that's in your brain?
It's a fraction.
There is a fraction.
Oh, that's not.
I did sing it to you guys yesterday.
And then it was like the square root or whatever.
Well, that's Pythagorean's theorem. What'd you say?
Plus opposite of b plus or minus the square root.
We're missing one little piece. B squared.
That's 2a.
2a, sorry. I was looking up above and wrote the wrong thing. There you go. Opposite of b plus or minus the square root b squared minus 4ac all over 2a is the formula for your quadratic. And where do we get the a and the b and the c from? From your equation. The a is always in front of the x squared, the b is always in front of the x, and the c is always in front of, or it's just like the number, it doesn't have a letter attached to it. If you're missing a term, like if there is no x term or there's no constant, then you put in a 0. Okay, so let's do one where we practice here. So if you look at this formula, or this equation I should say down here, what's my a, my b, and my c? Okay, so I'm going to start by plugging this in. I'm going to do opposite of my b, which is 3. So opposite of 3 would become negative 3. Plus or minus. Big square root sign here. B squared is going to be that 3 squared. Minus 4 times what goes in for A? 2, and in for C? 1. All over 2 times 2. Okay, and then we just try to simplify this as much as we can. We try to get it down to the best possible version of itself. So I'm going to work with the square root part first. So the 3 squared minus the 4 times 2 times 1. So I have negative 3 out front still. On the bottom here, or in the square root, I should say, 3 squared is 9. And then minus 4 times 2 times 1 would be 8. So what's 9 minus 8? 1. And then that's all over 4. Now, sometimes when we have the piece underneath the square root, it'll be an easy to square root number. Other times it won't. Like in this case, I can square root of 1. I just get 1. So I'm going to write that down here. I'm going to rewrite this as negative 3 plus or minus 1 all over 4. Do you guys remember what you have to do here?
You have to have like 2 answers or whatever.
You have to have 2 answers. So I always kind of like split it off into the 2 ways that it can go. You can take negative 3 and you can add 1 and then divide by 4. Or you can take negative 3 and subtract 1 and divide by 4. Try to squeeze that in there. So what does the top become?
Negative 0.1. 0.5.
Okay, so negative half. Because it'd be negative 2 over 4. That reduces. That's where we're getting the 1/2 from. And on the bottom? Negative 1. Those are your answers. Okay, that one wasn't so terrible because the square root does work out for us and it goes away, but you won't always have that. Sometimes you'll have a number that you can't just square root. So if you have like a square root of 18, let's say, we can't square root 18, but it could be broken down. And we talked a little bit about how to break those square roots down yesterday. And then if you can't do something, like for example, if we had an answer, I'm just going to write this over here to the side. If I had like 2 plus or minus 3 square root of 2 all over a 5, let's just say, I would want to look at these whole numbers, the 2, the 3, and the 5. If they were all numbers that could be divided by something, we would want to do that. So if it was like a 2, a 6, and an 8, then I could take a 2 out of everything and we would reduce it. So that would be really the only thing I would make sure you guys check is there anything we could take out and reduce? Now, that piece underneath the square root sign has a specific name. It's called the discriminant, and that's what's written down here. So that piece that's underneath the radical actually can tell you a lot about what kind of answers you're going to get before you even start this process. So if the number underneath the square root sign is positive, you're going to have 2 real solutions. So in that case up above, when we had the square root of 1 was positive. And so that told me I'm going to have 2 answers to this equation, and they're going to be real numbers. Okay. If the discriminant is a 0, so if underneath the square root sign, that b squared minus 4ac piece just zeroes out, then you're only going to have 1 solution. And it would technically be repeated because when you think about a parabola or even the quadratic form, it says x squared. The squared tells you there should be 2 answers out there. If you only can find 1, it's because it's sharing that point 2 times. It would show up twice if I factored the equation or something like that. If the number underneath the discriminant is negative, that means you're going to have imaginary numbers show up. So we've talked about those complex numbers. We talked about the I in the last section. So they can show up sometimes with our quadratic. So what I want us to do right now is just focus on practicing looking at just the discriminant part. So for this one, I only want to think about what is the b squared minus 4ac going to show up as for this example. So what number are we going to put in for our b? Negative 3. And I always put that in parentheses because you're squaring it. So no matter what happens there, it's always going to be positive. And then minus 4, what goes in for my a? And c? 2. Okay, so let's evaluate that. What would be 9 minus 40? Negative 31. So down here I'm going to say my discriminant would be equal to a negative 31. Okay, then it says how many roots will you have? So we're going to look up here at those bullet points. The last one talks about if the discriminant is negative, then there are 2 solutions. So there's 2 roots. But what type are they? Imaginary. Because if I had that negative 31 underneath the square root, the only thing I'd be able to do with that is take out an I. Okay, the last problem we have here is taking what we've been working with in our quadratic section here and just applying it to a situation. So this one is giving us this formula, and it's just modeling a woman's normal systolic blood pressure. So the blood pressure is represented by the letter P, and then that capital A is representing her age for the problem. They want us to use this formula to find the age to the nearest year of a woman whose normal systolic blood pressure is 115 mmHg. I'm not entirely sure what those letters stand for. I don't know. Do you guys know what those? Anyone in here have a medical, taken a medical class?
Millimeter.
I know millimeter. I don't know what HG would be though. Sure. Why not?
Sure.
Let's go with it. Okay, so they're not giving me the age, they're giving me her blood pressure. So they're actually giving me the P for this one. We want to figure out how old this person was for this situation. So 115 is going to go in for the letter P. And then I'm going to set that equal to this equation here. It's written backwards, okay, because we have that 115 at the beginning. You could have had it at the end. It doesn't really matter. What number would be our A? The B? And the C? Okay. I'm looking at those numbers. I don't want to even begin to try to factor this or do completing the square. I feel like that's just going to be a headache. It's probably going to be easiest because of the numbers we have to just go ahead and use the quadratic formula again, because they're kind of not great numbers. They're not whole numbers. Not all of them anyway. So in for B, opposite of B, we're going to do negative 0.05. Okay, underneath our square root sign, our B squared is that 0.05 again. Minus 4, the A would be 0.01. C is 107. And this is all over a 2 times 0.01. All right, let's just clean up the square root portion. So just this. And I would just use your calculator there. So take that 0.05, square it, and then subtract 4 times 0.01 times 107. You might have to round it. Does anyone have something there? I have a decimal written down. Okay. Oh, you know what? We made a mistake. We got to back this up a second. Don't erase everything. We just have to fix one number. When we're trying to solve a quadratic, it should equal 0.
Not 150.
Not 115. So let's move that 115 over. So I'm just going to come up here. Yeah, I missed that. That's on me. This fly needs to go away.
Yeah, I was wondering how you were going to use that. That's why I didn't.
Yeah. Okay, here's what I would do. You're going to want to subtract the 115 over here from the 107. So instead, that's a 0. And what would be 107 minus 115? Negative 8. So let's change that. Instead of plus, we'll write minus 8. So the only number we need to change in our formula here is that 107 needs to become a negative 8. That sounds much better. Okay, and then on the bottom, it would be 0.02. So let's square root that 0.0323, and again, you'll have to just round it. Let's go out 2 decimal places. What would that round to about? 0.57? Okay. Okay, now we're still just trying to figure out what her age is here. So we're going to think about both solutions. So if I add or subtract, so if I take negative 0.05 and I add 0.57 and then divide by 0.02, and then the exact same thing down here, but instead you're going to subtract. What do you get for the 2 answers? And the other one? Is it positive? Okay, so now you have to ask yourself the question, which one makes sense when we're talking about age? 26. He can't be negative years old. So she is 26 years old. So make sure that when you're picking what solution works better, you think about the context of the problem and what makes sense. Should it be positive or should it be negative? All right, any questions on that?